Practice number six, free response using Maclaurin series. Don't forget, you can always take any polynomial and make it into this polynomial equation. And so what I'm going to do with this one is f prime of, well, actually what we would do is f of 0, 2 is going to be equal to f of 0 plus f prime of 0 times x plus f double prime of 0, x squared over 2 factorial. Now, we don't need that last term because we're just going up to the first term. So I'm going to take this off, and we'll go to 1 here. And this says f of 0 is negative 4. F prime of 0 is what we're trying to find. X is 1/2, and f of 1/2 is negative 3. So we just solve for that. Add 4, and you get 1 is equal to f prime of 0 over 2. So f prime of 0 is equal to 2. That's showing it step by step. AP would give you full credit on that. It's known that f double prime of 0 and f triple prime of 0 find that third polynomial. No sweat. We can do that. So for part B, P of 3 of 0 is going to be, I like just f instead of P. F of 0 plus f prime of 0 x, f double prime of 0 over x squared over 2 factorial, f triple prime of 0 x cubed over 3 factorial. So we just plug in everything we know, which is quite a bit. We know that f of 0 was negative 4. We know f prime of 0, which we found from the previous one, was 2. X, f double prime of 0 was negative 2/3. 2x squared over 3. And then the next one is going to be plus x cubed over 3 factorial times 3. And this is times 2 factorial. So simplified, it's negative 4 plus 2x. One of these 2's will cancel, and you'll get negative x squared over 3. And I think this is going to be x squared or x cubed over 18. Is that what they had in the back? Maybe I don't have that one here. Thought I did. Okay. All right, well, that's it. Then that's the answer for that one. And then it says the function h has first derivative h prime of x equals f of 2x. It's known that h of 0 is 7. Find the third degree polynomial for h. So what they're doing there is if h prime of x is equal to f of 2x, okay, and we want to find h, what are you going to have to do to this? You're going to integrate, right? Okay. Now let me stop you for just a minute. This is a little glimpse of why we're doing this in the first place. But let's go back here. You have h prime of x is f of 2x. We want to find the third degree. So we already know the third degree right here, right? So here's what I want to do. I want to take the antiderivative of f of 2x dx. So let's do a little bit of something here. Let's change this thing, negative 4 plus 2 minus this squared plus this cubed over 18 dx. And we're going to replace x with what? According to this thing. What are we going to replace x with? 2x. So put a 2x here. So if I have that plugged in, now I can take the antiderivative of f of 2x pretty easily, can't I? Yeah. And so what we're looking at is the integral of negative 4 plus 4x minus 4x squared over 3 plus 8x cubed over 18 dx. And you're going to get negative 4x plus 4x squared over 2 minus 4x cubed over 3 times 3 plus 8x to the 4th over 4 times 18 plus what? Yes, plus c. You can find out what that plus c is. And we're going to do it. So this is equal to negative 4x plus 2x squared minus 4x cubed over 9. Let's see. I think I can make this plus x to the 4th over 9. Yeah. I did it already, yep. Yep, okay, plus c. And then I go back to find that plus c. They're saying h of 0 is what? 7. Okay, so this is h of x. So h of 0 equals 7. So h of 0 equals 7. 7 is equal to negative 4 times 0 plus 2 times 0 squared. 4/9 0 cubed plus 0. Why am I doing this? C is equal to 7, right? So my final answer is going to be that for h of x. Perfect. Perfect.